Okay, here we go with another moments question, beam calculation. I've got a conveyor belt this time which moves packages in a warehouse. When the conveyor belt stopped, packages were in the position shown. So I've got support A and support B supporting the weight of each of the three packages. Some of the weight going down that leg, some of the weight going down this leg. It says draw the free body diagram for the system. Well, a free body diagram is just a line to represent the beam or the conveyor belt, an arrow to represent support A, an arrow to represent support B. These are forces, reaction forces upwards. We've then got an arrow representing the first box of 23 newtons, an arrow representing the second box of 36 newtons, and an arrow representing the third box of 64 newtons. Now we need to know the distance each of these is away from A. There's 3 more arrowheads. And they are 6.3, 4 and 1.8 meters. The final distance is the distance between A and B, the length of the conveyor, and that is 8.7 meters. It says calculate by taking the moments about support A. So we're going to put a pivot point there and move the conveyor belt. First thing we can say is the sum of the clockwise moments is equal to the sum of the anti-clockwise moments. We can also say that the moment is equal to the force times the distance. So let's see what we've got. Well, the 23 Newton force is a clockwise force, sends the beam in a clockwise direction around A. So we've got 23 newtons times 1.8 meters plus 36 newtons times 4 meters plus 64 newtons times 6.3 meters. And that is all equal to the reaction at B multiplied by, which is our unknown force, multiplied by the distance 8.7 meters. Let's just work a few of these out. 23 times 1.8 is 41.4. 36 times 4 equals 144 plus 64 times 6.3, 403.2, all equal to the force at B, which is unknown, times 8.7 meters. Now we need to get B on its own, so we need to transpose that formula. So we divide both sides by 8.7, and lucky for us, these two cancel each other out. So we just find the sum of these, divide it by 8.7. 3 plus 144 plus 41.4 equals that, divided by 8.7 equals, and the result of B is 67.7 newtons. So we now know that B is 67.7 newtons. It then says determine the reaction at support A. Well, we know that the sum of all the upward forces has to be equal to the sum of all the downward forces, otherwise it would be moving. So all we do is we add up all the forces. 23 36, 64 newtons, and that is going to be equal to the sum of A and B. 23, 36, 64 is 123, and that's going to be equal to A plus B. Well, we can just take B over to the other side and make it a minus. So minus 67.7 plus 123 is equal to A. So minus 67.7 equals A is equal to 55.3 newtons. Okay, let's see what else we're asked to find out. The conveyor belt is driven by a gear, which is shown below, large gear and small gear, and a gear in between that drives the two. State one advantage of using a gear drive over a belt drive. No slip. Of course, slip could be an advantage as a safety feature, but not in this case. State the name of gear A. It's an idler gear. Describe the effect gear A has on the output speed. Well, it doesn't have any effect on the output speed at all. No effect on speed. However, it does have an effect on the direction. It will keep output gear in same direction as input gear. So we could draw that on there. That's going in that direction, that's going in the opposite direction, which means that is going in that direction. State another part of the system makes use of the mechanism shown below. State the names, so just identifying what they're called. Part A is the worm and part B is the wheel. Important to remember that a worm only has one tooth, so you get a maximum reduction with the worm and wheel system. Also, part 2 cannot drive the worm back, so as a safety feature it can be used to prevent part 2 slipping.